Why do chain checkers read too high? A chain checker or indicator is a superb tiny tool to assess your chain condition. However, they are still criticized a lot in cycling community for reading too high. Are they really that bad, and why does this happen? We've got a used 11-speed Shimano chain here. As required, let's take a fair bunch of measurements with a common chain checker. This one has got a scale of 3 marks, 0.5, 0.75 and a full percent. Once a tooth makes its way through without any force applied, the corresponding wear mark is reached. 0.75, 0.75, 0.75. None of the measurements is below 0.75. I would even say sometimes it's just a tiny bit before the final mark of 1% is reached. And now let's assess this chain condition with a Henning method. In an easy way, against a brand new 11-speed Shimano chain, which has just been cleaned from packaging grease and prepared for waxing. Both chains are sized to 107 links. The used chain is visibly stretched. But how much? A vernier caliper will tell us. 0.259 inch or 6.57 millimeters. Since all chains have a pitch distance between pins of half an inch, 107 links of a brand new chain roughly amount to 53.5 inches of total length. So, elongation percentage of this used chain is 0.259 divided by 53.5, amounting to approximately 0.48%. And the indicator gave us at least 0.75. Why so high? A worn chain becomes longer, and this is referred to as chain stretch or elongation. Let's have a look at this illustration of chain components by Bike Radar. Rubbing against each other, both the bushings and the pins wear out, which leads to the elongation. However, the bushing outside edges also rub against the rollers, and both wear out as well. But this type of wear, referred as slop, does not lead to elongation, it just makes the rollers sloppier on the bushings. Thinking of chain wear as a combination of stretch or elongation and slop is a key to eliminate confusion. Since a common chain wear indicator pushes apart two rollers of a chosen segment, it measures both the elongation of the segment and the slop of the two outside rollers. Unfortunately, there is no unified standard on this kind of measurement, so each chain checker can interpret 0.75% wear in its own way. In our example, there is just 0.48% elongation behind this reading, and the rest goes for slop. To be honest, a checker is not to blame. If you look for a description of your tool, it will probably say checks the degree of chain wear instead of checks the percentage of elongation. So it does what it promises, gives you an estimate of combined wear to decide on chain replacement. By the way, different chains wear in different manner. Some tend to show more elongation over time, while others slop. Measuring the mixture of both, a chain checker can stay versatile and serve more types of chains. The confusion is also fueled by a true fact that chain rings and sprockets life is mostly affected by chain elongation and not slop. Probably this leads to a common mistake that chain wear equals elongation, and then to the confusion of the high readings of a chain checker. Why do we measure slop then, if it's irrelevant? Should we better measure roll elongation on our chains? These are some interesting questions for the next videos. As for today's one, regarding the chain checkers, I hope we've made things clear.